Hey guys, Halloween is coming, and so is my second video on flexible filaments. Oh, this is so uncomfortable. In the last video, we talked all about TPU, which is the most common flexible filament, and it's awesome. I love TPU. Everything about it is awesome, and if you haven't seen that video, you should go watch that first. But in this video, we're going to talk about more flexible filaments, but some of the more exotic ones, most of which are not TPUs, but still flexible, and some of them are kind of fun. As you can tell, I'm kind of sick, my voice is going, and I got a lot of stuff to show you anyway, so let's just jump right into it. This whole second video was inspired when I found this ancient relic in my 3D printer room. Flex Eco PLA. This was July 2013. This filament is 9 years old. This is not TPU, this is PLA Flexible. This one has been discontinued. I cannot find really anything else except for a single brand from a thing on Amazon I've never heard of. Ataraxia. Oh neat, what is this? Wow, it comes with a reusable vacuum bag. Oh, it's very soft. Alright. Since we're looking for exotics in this video, I went with two Ninjateks that are at opposite ends of the spectrum. One is Ninjatek Chinchilla, which is 75A, and it's labeled as a TPE, not TPU, so that broader class of elastomers. And it's a whole 10A below the softest from the last video. And then we have the Ninjatek Armadillo, which claims to be a TPU, but is 75D. It's not even on the A scale, which puts it closer to some of the standard filaments and probably resembles nylon more than anything. And the last filament was inspired by the YouTuber Zach Friedman, who explained how polypropylene is a super interesting filament and worth exploring even though it's a royal pain to print. It doesn't stick to anything except other polypropylene, so you have to put adhesive polypropylene sheets on your build plate, which leads to two other problems. As Zach Friedman says,
a heated enclosure is mandatory because this stuff warps if a cool person thinks about it.
And since you just printed polypropylene on polypropylene at polypropylene melting temperature, they are now permanently fused, which means you're taking that sheet with you. Also, like other flexible filaments, there's always a risk of it buckling inside the filament path, which led to one of the craziest extruder jams I've ever had. Where is it? How did it all fit in here? That is insane. On the other hand, it's chemically resistant to everything, which is why it's used everywhere in food storage and in industrial fluids applications. It also has spectacular fatigue and wear resistance, and it's one of the only filaments with density lower than water, which makes me want to build a toy plane or boat with it. So here's the 5 new filaments that we printed, both the Ninjateks. I had a heck of a time getting these to print. You can see that the print quality, I printed until I got 2 good pieces. So here's a good 6mm piece, and here's a good 2mm piece. So I'll use those. Same with Armadillo. The stringing was just through the roof, and I had some issues with, I don't even remember anymore. I had all sorts of issues getting this to print. This is the Form Futura Flex Eco PLA that you can't get anymore. This would not stick to the build plate for my life. I felt like I was lucky to get a 2mm piece. I tried everything. I tried blue tape, I tried Kapton tape, I tried textured side with glue, PEI, smooth PEI side, with and without glue. I guess it'll be an interesting history lesson and see how it compares to the Ataraxia Flex PLA. And this printed perfectly on the first try. It even picked up a bunch of stuff from my build plate. Feels a lot like TPU. And then here's the Dark Horse polypropylene. That warp is crazy. I'm surprised I even finished printing this. It was flexed on the build plate while it was printing, so this was jammed into the nozzle. But anyway, this surface right here, this 6mm is pretty good. And then here's a piece that's 2mm. Oh, it's kind of slippery. That really didn't stretch much before it broke. I think this one is more bendy, but not stretchy. Ataraxia Flex PLA. It's definitely very slippery. Yeah, I can't even get the vise to hold it. Let's should go back and try that with the regular TPU, because I didn't give the regular TPU a twist like that. So this is the regular TPU from my last video. And what I want to do is do the exact same test, because I really didn't abuse this one too much in that video. Oh, this one definitely has more rebound. Like, I feel like a spring. Like if I let go of this, it's gonna flip back around. The other one kind of, maybe it just started deforming, and thus it didn't have a lot of kind of angular potential energy to spring back. I mean, there's a bit of a mark there, but it's pretty much the same as it was before. Didn't stretch at all. So this one, the Flex PLA, stretched a little bit, it deformed a bit. All right, Flex PLA 2mm. I'm hoping we can break this one. It's too slippery. I can't hold on to it. That's a workout. I didn't quite break it, but it did stretch, and it didn't come back. Oh, it's kind of warm. All right, next up, Chinchilla 75A. This is the best looking print I could get for both these parts. All right, as expected, it's just floppy. So this is the weakest, the softest of all the materials that I've tested so far. You might be able to see the way it's squeezing the middle. It's very soft and pillowy. Oh yeah, it's got some good, yeah, it's got some good stretch to it. Well, it's standing up much better than I expected. I'm not really sure what else to do with this one. So there's the original length, and then here's the stretched length. Oh, there we go. So as far as I can tell, this Chinchilla behaves almost exactly like the foam on like gym equipment or like handlebar foam. Next is Armadillo. Had some problems printing it, but did eventually come out okay. It's technically TPU, at least they claim it's TPU. So this is the TPU, the regular 95A TPU. This is the Armadillo. Oh, this is pretty cool stuff. I think this is doing exactly what nylon would be doing. Oh, actually, you know what's interesting? It lost some of its springiness. If you remember, I did this at the beginning before I started flexing it, and it was much more bouncy. It doesn't break, but it's clearly changed. Oh, wow. It's so warm, like really warm. Yeah, we got a little bit of stretch in that guy. Just a little bit. So I'd say the Armadillo is pretty good. Pain in the ass to print. Now let's do Armadillo 2mm. All right, that's about what I would expect. It's really not stretching at all. Well, I cannot pull it apart. So instead we're gonna twist it apart. There we go. Polypropylene. Okay. So he's got some springiness to him. It's got some nice properties to it. Oh, interesting. Seen it breaking along the lines. I mean, it's still holding together okay, considering. So with this one, you can start to see the whitening, micro voids forming inside the material. It's definitely a little bit weaker. Well, I didn't expect it to break so soon. Wow, it just tore like along with the infill lines. All right, so you might recall, this is the TPU vase that I printed from the last video. And this thing is still going strong even after doing 20 takes of that clip where I'm banging my head with it and smashing it on the table, crumpling it up. My kids actually played with it and they filled it with water. And I even found it the next day, still full of water, even after all this abuse. The layer adhesion of this TPU is just spectacular. The strength is spectacular, the impact resistance. This is gonna be my baseline for everything else that we look at. Flexible PLA. And this thing feels very similar. This should technically be softer than the gray one from my last video. But it actually feels very similar in terms of strength, at least of the vase, in vase mode. It seems to be able to take some abuse, just like the TPU. So that flexible PLA is pretty cool. I'm not sure if it has any advantages over TPU. It wasn't particularly expensive, but neither was the TPU. The next one I have is the polypropylene. And this, oh, it feels so nice. I don't even know how to describe how this feels. It's just, it came off the printer and I just want to pet it. It's got like a weird smoothness to it that I can't describe. This was probably the best print I got. Vase mode is of course very easy for flexible filaments because it's really just doing one continuous spiral of printing at a fairly constant pressure, so it doesn't have to kind of jerk the filament around much. It's definitely flexible and it definitely feels stiffer. It feels stiffer than the TPU and the flexible PLA. It definitely bounces back. One thing is when you do bend this quite a bit, it does start to whiten. It kind of does that milk jug thing. The sharp bending, creasing creates like micro voids in it that change the way the light reflects off of it. And here we have Chinchilla. This one, man, was this tough to print. This is 75A. In the last video, the softest thing I had was 85A. This thing, I can't even hold it upright. It's just floppy. One thing you'll notice is that the layer adhesion is absolute garbage. These layers don't stick. When I was getting it off the build plate, it started to pull off right here. I did get a better print out of it later. This was a sleeve for a hammer. I wanted to see if I could hold it in a hammer. Once I got this working though, I tried to reprint this and it came out even worse. So I think it's something to do with like the single layer. I don't know. I don't know how to explain it, but I could not get a better vase than this. This is the Ninjatek Armadillo, which is 75D, not 75A. And it's technically a TPU. It's much, much more rigid than any of the TPUs. Oh, there we go. All right, so that's the Armadillo. I've done this test with nylon and this is very much like nylon. So maybe I should save this for the nylon video. So I've been having fun looking at compliant mechanisms, and they're a really cool thing that I've discovered. I originally discovered it through the Veritasium channel, and you should totally check out that video. BYU CMR, I think that's Brigham Young University Compliant Mechanisms Research. This is could replace a light switch. The idea is that you could actually print this as one giant extrusion and cut off slices of it. You know, obviously one of the most relevant applications for this would be space. You know, astronauts may not have a huge supply of screws and lubricant and all these things that you would use to make a switch. And even then, even if they do, those things can rust, they can wear down. They have moving parts that rub against each other. You pick a good wear-resistant plastic and you can print a lot of stuff in your 3D printer. This is called an orthoplanar spring. The idea would be that you don't need metal to create this spring. That you can, again, you could create one giant extrusion and cut off slices of it, or you can just print them flat on your 3D printer. And check out this one made in polypropylene. Listen to this click. Ah. And look at that quality, that perfectly smooth top and bottom surface. You almost can't even see the layer lines. And there's a reason for that, because this isn't 3D printed. I actually got on Amazon and ordered a 3/8 inch thick piece of polypropylene sheet and took it to the local fab lab and milled it with an 1/8 inch end mill. This is actually milled on a CNC router because printing this stuff is hell. I did eventually succeed at printing one in polypropylene, and it does kind of work. but man, look at that warp. It was just barely a win. This was another polypropylene print that could be a good lesson for teaching middle schoolers about quadratic equations. You have the bottom right here stuck to the build plate, and then you have this nice curved surface here. This is probably the best print I got. I had a solid sheet of the polypropylene tape. As you can see, it came up with it. So they recommend that if you don't want this stuff sticking to your part, then print with a raft, which is basically a sacrificial first layer. It's probably the first and only thing I will successfully print in polypropylene that doesn't look like a taco. This was cleaned up a little bit. There was a tiny bit of stringing and a bit of weird crystal-like growths. This part was printed like this with this whole surface down. These are technically overhangs right there, but they're not too bad. Polypropylene didn't dose. It wasn't so bad on those overhangs. I'm reasonably impressed with that. Man, look at that warping. It's like that is not flat, like not at all. When you do this box, this is relevant for any filament, you need to orient it and check your slicer before you actually print it. Here's the hinge, and you want to make sure that it does the first layer this way. If it prints the first layer this way, it'll tear off real easily. So I actually printed this on the build plate at like 45 degrees, and then checked the slicer to see if it was right, and it was actually the wrong way, so I turned it back this way 45 degrees, and it did it the right way. Armadillo, this is the orthoplanar spring. Doesn't have great elastic recovery. I'm not sure I would trust it with these compliant mechanisms. It comes back slowly. Hey, I made a cool box, but look at that. It's a box full of string. Happy birthday. Super excited about the possibilities of what you can do with this. Hey, if you have any ideas, to me, this just feels like it opens a world of possibilities, being able to do multi-material prints like this. Rigid parts connected with TPU parts. Now, of course, this worked on my printer, which is a single extruder printer, only because I only needed one filament change. If you want TPU and PLA or TPU and PETG interspersed in your volume, where you're doing filament changes basically every layer, then this probably isn't a great idea. To expand on what I did in the last episode where we built these textured phone cases, I should point out that if you leave the top and bottom layers off, you set them to 0, but you leave the walls on, what I did was I basically printed this 3 millimeters thick, and then 1.5 millimeters I embossed text. Because that text created new walls, it printed walls there, even though the rest of the background was textured. You could combine this with multicolor printing, so that's what I did. I made the infill a little bit thicker here, a little bit more dense, and then I changed it from green TPU to the yellow Armadillo. Oh hey, this is a good time to introduce my new channel. It's not my new channel, it's this channel. It's my new name. I am officially rebranding as Obsessive Engineering because, as you can tell, that's my thing. I get obsessed with things and I like to play with them and pry everything about them and then share my experience with others. So, welcome to Obsessive Engineering.